Hello everyone and welcome to a new Sega Mega Drive game dev tutorial. In this lesson we're going to learn how to program a camera which follows a character around on a big map in a 2D game. So by the end of this lesson you'll pretty much be able to do what you're seeing on the screen now in this Zelda example. Let's first take a look at our jumping off point, and the code I'm going to take you through now is all stuff that you've already studied in previous lessons, but I'm going to go through it very quickly. If there's anything you don't understand, then feel free to check back on the other lessons just to give yourself a little refresher. Okay, so let's kick things off by looking at the resources.res file, and as usual this is where we upload all our resources to the ROM, and we have our link sprite, and we also have the village map. So we've created a tile set, we've created a map, a palette, and also the sprite. So this should all look very familiar. If not, then you can just check back on the previous lessons. Before we go into the main.c file, let's take a look at the graphics themselves. So remember we will need to have this as 16 colors only, maximum of 16 colors, and also make sure that the color mode is set to index and not to RGB. You also need to take care of the size, both the horizontal and vertical size of both the sprite and the map graphics. So remember the Mega Drive is tile based, so the graphics are all tile based and each tile is 8x8 pixels, so you need to make sure that the length and width of all your graphics are a multiple of 8. So we've made sure that's the case here, and also make sure that when you save the file you save it as a PNG. You can see here that both of these graphics are in our res folder, so this is the resources.res, so that all should work fine. If we now go to our main.c file, you'll see that we've already got the code written here. So if we go to the very top, first of all we have the include genesis.h, of course include SGDK, we're including the resources.res file by writing resources.h. We've got the map created, we're calling it the level map here. We've got the tile user index assigned to the IND, the index here, so that we can correctly allocate all the tiles in the VRAM. We've also got all the sprite variables created. We've got this handle inputs function here. We're doing all the basic D-pad controls, moving left and right, up and down, and again, like everything else, we covered this a while ago. If we go here, we got into actually our main section here where we're initializing the sprite engine, we're allocating the palettes, we're also setting up we're loading the tile set into VRAM, and we're putting the map on the screen, we're putting the sprite on the screen, and so on. And of course we've also got the while loop where we're make sure including our function to do the controls, as well as the setting the sprite position so it keeps updating. We've got the sprite update, and we've also got the do vblank process, as we always have for these. And if you take that code as it is and compile and then load it up, this is the result you would get. So we've got the map loaded, and we've also got our sprite loaded, and you can move the sprite around, but unfortunately there's no camera, so the sprite will just go off screen somewhere else on the map, but there's no camera to follow the sprite at the moment. So of course that is what we're going to do in this lesson. Before we get into the camera code proper though, I just want to do a couple of things. The first of all is taking this function, this handle input function, which controls our D-pad controls. I'm going to Control X to cut it, and I'm going to paste it and put it at the very end of our main.c file. If we were to save and try to recompile now, we'd actually come up with an error, and that's because you see where it's got handle input in this while loop in our main game loop. Well, when the compiler gets to that moment, it will think, okay, we've got this handle input function, but I can't find where the function is actually defined and what the code inside it is, and you'll start to panic. As I understand it, most newer programming languages, they'll continue to look in the rest of the document, and of course they'll find it at the bottom where we put it here, but C is a bit different, it's a bit lazy, it won't look at the rest of the document, it will just panic and it will refuse to compile. So what we need to do is we need to copy just the first line of handle input, everything in the line before the first curly brackets, and then we are going to paste that just before where it says int main. So this is where we had the function before actually, and we're going to add the semicolon too. If we were now to save and compile, we'd actually have no problems at all. It'll work just as it did before. Now this is a purely cosmetic change, so it doesn't affect how the code works at all. It's just that in C language it's standard to put all the functions at the bottom of the file and then create what's called these function prototypes, which is just the first line of the actual function, and put it higher up just before where the main starts. Organizing the main.c file that way is a bit neater. It means that you can look down the program from the very top and you get to the main game loop much quicker, but you just have these lists of the different functions including the program. And if you're interested in finding out more about what the functions do, then you can go right to the bottom of the file and then look at what the functions actually do there. Doing that is entirely optional, but I recommend it because especially as we create more functions, for example the camera function later on today, you'll see that it looks a lot neater. In the previous lesson on different data types and 8-bit, 16 and 32-bit numbers, I mentioned that when we do the player movement, it's best to use the fixed 32 data type. So this just means that we can have a very large number, and we can also create decimal places. So if you move, you don't have to move either one pixel per term or 2 pixels per term. You can move maybe 1.5, 1.2, which is especially important when we eventually come to doing any jumping physics. You can see I've already begun the process of changing it from our player movement variables from an int data type to the fixed 32 data type. And since we can use decimal points now, let's make the velocity, the movement speed, as 1.5 instead of 2. We also have to make another change before we're finished with this. So remember, when we're doing the add sprite and some other functions, what it does, it takes an integer rather than a fixed 32 data type. So we have to convert the fixed 22 data type to a data type that the add sprite function can accept, and we use the fixed 32 to int function and open the brackets and simply put the fixed 32 number inside. We've already done it for link x, which is the x coordinates of our link character. Now we need to do the same for link y. So again, fixed 32 to int. Make sure you pay attention to the capitalization of some of the letters in that function, and then put link y inside the brackets, and that will make sure that our new number can work with this function. And we also have to do the same with the SPR set position too. Rather than typing it out again, I can simply copy and paste from what we did with the SPR add sprite function. And that's all we need to do. So our movements have now, the variables for the movements of the main character are now fixed 32. We can use decimal places rather than whole numbers as we did before. And you can see that the movement speed changed. Now it's 1.5 per cycle rather than 2 per cycle. As I said in the previous lesson on data types, we're going to be using fixed 32 for all player movement from here forward. So it's good to get used to it, even though it's not quite so useful in this particular example. Okay, now with those two out of the way, let's get to writing our camera code. So first of all, we're going to create the function prototype there next to where we create our other function prototype, and then we're going to copy and paste that, and we're going to create some open brackets. So just as we did with the handle input, and this is where we're going to put our code. Before we get really stuck in writing the code, I just want to illustrate what we're going to be doing conceptually. So here we have Link here, and around him is this black box. Now the black box represents the screen, so it's 320 wide by 224 high, and that's going to be our screen. You can think of it as our camera, and Link's in the center. We're going to try and keep him in the center of the screen at all times. And if you zoom in, we can see that Link has a pink box around him, and that represents the sprite size itself. In the top left hand corner is the coordinates of Link X, and Link's Y is where he is, and in the top left hand side of the black box are the coordinates of the camera, so that's going to be camera X and camera Y. Now we're going to create those variables now, so just think about this how it works conceptually, and I hope you understand the code we're about to write. Let's start at the very top of main.c, and let's create those variables so we can keep track of the position of the camera. So I'm going to type here int, and then we're going to call it whatever you like. I'm going to use these very descriptive variable names here. You don't need to make them as long as I'm going to make them, but I just want to make the whole process absolutely clear. So we're not going to assign anything. We could make it equal to 0, but actually we don't have to assign a value right now. We can just create the variable and do a semicolon without making equal to anything, and we're going to do the same with y. So we have current camera X and current camera Y. The next thing we have to do is decide at what point on the screen do we want the camera to move to the left, to move to the right, to move up, and to move down. Since this value isn't going to change in the process of our program, we can make this a constant. To create this constant, I'm going to use the hashtag define way. So do hashtag define, and we're going to give this this constant a name. So again, I want to give this a very descriptive name, so it's going to be very long. Feel free to give it a much shorter name, so long as you know what it does or what it refers to, then that's fine. So I'm going to call it how underscore far underscore to left before for the camera moves. And next we need to give it a value. In order to make this decision, let's take another quick look at our map. Since the screen is 320 pixels wide, you might think that, okay, if Link moves gets maybe 160 pixels either to the left or to the right, that's when we can move it. But of course, the Link character, the X coordinates are on the top left hand corner of the sprite, so we have to shift that maybe to the right a little bit so that it falls the point at which the camera moves falls in the middle, and we have to do the same with the top as well. Remember, the Y coordinates are got from the very top of the sprite, so we want to move it maybe to the middle of the sprite. So again, we're going to have to add a few pixels to make sure that Link stays in the center. Don't worry about it too much though, we can always change these values a bit later, so let's do a rough estimate rather than calculate the things exactly. So for now I'm just going to do it as 152, and that should work pretty much okay. As well as doing a constant to see how far to the left Link moves on the screen before the camera's going to shift, we're going to do the same for how far to the right too. So let's just make this 153. I said we can change this later if we need to. We had another one for up and another one for down, so how close to the top of the screen Link needs to get before it moves. Now remember, the vertical resolution is 224, so we're going to get roughly in the middle of that, take into account maybe where, as I said before, that Link, the top of the sprite is actually, maybe we need to shift it down a bit, but it doesn't matter too much. And let's do the same for the bottom, so how far from to the top of the bottom of the screen does he have to be before the camera moves. And bear in mind, when we're talking about the top and the bottom of the screen, the Y coordinates of the top of the screen are actually 0. It begins at 0, and as you travel down the screen it increases 1, 2, 3, 4, 5, 6, 7, 8 all the way to 224. Okay, that's enough variables and constants for now. Now let's go back to the camera function and we'll start writing some code. Now the first thing we need to do, we need to create a variable within this function, and we're going to use that variable to store the player position, the X and Y coordinates of the player, of Link here, in integers, in a whole number rather than the fixed 32 that we had before, because we're going to need an integer to do various things rather than using a fixed 32 number. Again, I'm going to give this a very descriptive name to make sure that we know what this variable stores, and so that we can differentiate it from the other variables we're going to create. So so first up, start with int as the data type. We might change that a bit later, and we're going to do player x map integer. So where the player position on the x coordinates of the player on the actual map, and then we used this function before where we convert our fixed 32 number, Link X, to an integer. And as a reminder, an integer is just a whole number, so 1, 2, 3, 4, 5, 6 and so on, rather than 0.5 or 2.4. Some of you may be wondering why we created this variable inside our function rather than at the top, as we did with all the other variables and constants. Well, there's a reason for that. So any variable that's declared up in the top here before we begin the main part of the program, this is called a global variable or a global constant. So we can use this at any point in our program. So for example, I can take Link X here and I can add or take away 15 or do anything I want with that, and the compiler doesn't have a problem. It will work, it'll be fine. But if I try and take this variable we just created here, we created inside our function, and if I try to use that and try and do something with that outside of that function, for example in our while loop here, it's going to come up with an error because it doesn't recognize it doesn't know where it is, because this variable only exists within the function. Now you might wonder, why would we do this? Because it sounds like a worse still than just making it a global variable. We should just maybe declare this at the very beginning of the program so we can use it everywhere. But that means it's going to stay in RAM the whole time, and I said the Mega Drive is quite limited in RAM, and we don't necessarily want to load up RAM with all these variables we're not going to use in other places. So since we're only going to use this particular variable inside our function, we're just going to declare it inside our function, and when the function's over, it's going to get kicked out of RAM until the next cycle. So this is generally a better way of doing it. You can see I just also created the another variable, since this time keeping track of the where the player is on the map in terms of the y coordinates and as a whole number, so I'm going to store that in that variable. And the next thing we want to do is to find out where the character is on the screen. To explain what I mean by that, let's take another look at our map. So we have the camera moving around here. This is the black, remember the black box represents our screen we're going to see on the TV. And link here, remember the link x, or the integer version we just created of x and y, of the link coordinates. That's where he is on the map. So that's from the top left hand corner of the sprite here. Now if we want to get where he is on the screen, we're going to have to take that value, and we're going to have to subtract the coordinates of the camera. Remember the coordinates of the camera in the top left hand corner of the black box. So if we take the player coordinates on the map and subtract the camera coordinates, then we should get where the player is on the screen and not on the map. So let's go ahead and create some new variables within this function. So again, we're going to make it an int, and let's make it another very descriptive name for the variable. Again, you can make these much shorter as soon as you understand what's going on. I'm just going to make it as descriptive as possible for the sake of this tutorial, and let's call it player X position on screen to differentiate from the position on the map. So how do we calculate this? So as I said just now, we're going to take the player position on the map, so in this case the x coordinates of the player, and we're going to subtract the position of the camera, the x coordinates of the camera. We also need these y coordinates, of course, the y coordinates of the character on the screen, so we can simply copy and paste there and make a few changes, and we can create another variable that keeps track of where the y coordinates of the character on the screen are. With that done, we're going to start to calculate the new camera position if the player's moved, and if we need a new camera position, and then if we need to scroll the screen or not. So we're going to create some even more integers, so don't worry, I know we're doing a lot of code here and I like to break things down step by step, but if you are a bit lost, just stick with it, and at the end at least you'd have a template that you can use. I'll go through the code again very slowly, and then we can explain things a second time too, so don't worry if you don't get it straight away, it's quite complex. And so the next 2 inches we're going to create is the new camera position of the new XY camera position coordinates. And next we're going to create an if statement, because we need to check something. So whenever we need to check something, for example, check if there's buttons been pressed or anything else, we're going to have to create an if statement. So if we do the open brackets, and whatever happens in the open brackets is a condition. So if this is true, then do the things in the curly brackets. So what we're going to check for here is the player X position on the screen. So is that greater? Is that more than the how far to the right before the camera moves? And if it is further, then we obviously going to have to update the camera with a new value, because that means the characters reached the furthest edge of the screen that we dictated before. And we're going to have to move the camera, we're going to have to update the camera position. So in the curly brackets, we're going to write what happens if the player X position on the screen really does go past that point where we want the camera to move. So in that case, in the curly brackets, we're going to write new camera X equals, and then we're going to update what we're going to say what the new camera position should be. So it's going to be the player X, the integer value of the player X on the map, the X coordinates of the player on the map, and we're going to subtract the how far to the right of the screen value that we set before. Of course, the next step is to check the other side of the screen. So if the player approaches the left hand side of the screen, if it gets to the point on the screen where we said, okay, if it passes this side of the left hand side of the screen, then we're going to have to shift the camera to the left a bit. So we're going to do else if, then open brackets, and then player X position on the screen, and if that's less than the how far to the left before the camera moves constant that we defined before, then again we're going to have to create a new camera position. So this time we're going to do the player X map integer value, and we're going to subtract the how far to left before the camera moves. And finally, we have to take into account the possibility that neither of these are true. For example, if the player didn't move at all, or if the player did move but they didn't go across any of the boundaries we set. So we use a final else. So if the above two aren't true, then the new camera X is simply going to be the same as what it was as the current camera X, which is what it was the camera position in the last cycle. We also need to do the same for the Y coordinates of the players to see if any of those have crossed over the boundaries we set, so that the camera has to move on the Y axis too. And I'm just going to write an extra note here so that the code's very clear. So this little section here that we're writing right now is to see if the players moved, if they've crossed any of the boundaries that we set, and if so, then we're going to update the camera position. So whenever you're copying and pasting code, you have to be very careful, make sure you update everything you need to update, and that's what I'm going to do here. Just to re-emphasize a point I made before, let's go back to the map. So remember, at the top of the screen is actually 0 in the Y coordinates, so it's 0, and as we go down, it's eventually going to reach the bottom of the map, which I think is around 1024 or 28 if I recall correctly, and this position here will be 0 in the x-axis, and it will increase as we go to the right, and this will be the end of the map, the I think 1024 or 28, I can't remember how big the map is. If we look at the Y, as I continue to alter what we copied and pasted before, if you look at the Y coordinates version of the code we had, it seems a bit counterintuitive, because we were saying if the player Y position on the screen is greater than how far to the bottom before the camera moves, and that seems pretty counterintuitive. But if you just saw the previous example, I think you'll understand why that's the case, because of course the top of the screen is actually 0, and the bottom of the screen, it gets the value of the Y coordinates increases. Okay, the final thing we need to do before compiling and trying this out is to see if just to do a check if has the camera position changed, and if it has, then we have to actually scroll it so that it scrolls on the screen. So let's do that now. Since we're going to be doing another check, we're going to write another if statement. So again, if open regular brackets and then open curly brackets, the inside of regular brackets is the condition we're going to test, is this true or not? And what we're going to test is true or not is if the camera position has changed, and we can do that by comparing the new camera position with the current, or you could call it the previous camera position, what it was the previous cycle. So when we do a logical comparison, we always use 2 equal signs, whereas when we're assigning a variable, we use just 1. So for example, in your code, you might have something like the number of lives. If the number of lives equals 0, then do some kind of game over code, as I'm doing in this example here. I write if rather than phi. So we use these kind of if statements quite a lot, and we use these comparisons a lot. Now, if we use exclamation mark and equals, it means if these two sides are not equal. If that's true, then do the stuff in the curly bracket. So that's what we're going to do here. We're going to do the current camera X. If that's not equal to the new camera X, then it means that there's been some kind of change on the X coordinates, and also of course we want to check on the Y coordinates too. Now if we do the 2 and signs here, it means that both sides have to be true, but actually we can do an either or situation here. If either the Y coordinates of the camera have changed, or if the X coordinates need to change, then we're going to do some kind of scrolling, and so we're going to use these 2 vertical lines, which means or. So in this case, if either the current camera position on the X coordinates changed, the X axis is changed, or is changed on the Y axis, if either of these are true, then we're going to do the stuff in the curly brackets. Speaking of the stuff we would need to do in the curly brackets, first of all, we're going to have to update the current camera, the X coordinates and the Y coordinates of the current camera. So remember, current camera X and current camera Y, these were global variables. We declared them at the very top of our file here, and that's because we want them to stay in RAM, because we need to keep track of these values, because after we go through this cycle of the CPU, it's going to be remember 60 cycles per second. The next cycle is going to check again, has the player moved, has the camera moved, and so on. So we need to keep this value up to date. So we're going to make the current camera X equal to the new camera X, and current camera Y equal to the new camera Y. So we keep that situation up to date, and next we're going to have to scroll the screen, because there's obviously been some, if that's true, then there's been some kind of movement on either the X or the Y axis, or maybe both. So we're going to map scroll to, we're going to use this function that we learned in a previous lesson, and we're going to choose which map to scroll, which is the level map in this case, and we're going to scroll it to the new camera X and the new camera Y coordinates. Of course, in the code we just wrote before that, we've made the current camera X equal to the current new camera Y anyway, so we could have wrote current camera X and Y here instead, and it wouldn't really make a difference because we've made them equal now anyway. With that done, we are finally ready to save and compile. So if I do so now, let's see if the code is working, and it's not. So I've obviously made a little mistake, and I think I know what mistake I made. So remember, we've created this function, this camera function, but we haven't actually called it in our game loops. Remember, this while loop here is our main game loop, and we have to call the function. We have to, tell the SGDK, hey, we want to use this function in our game. So let's put this just after handle input, and don't forget the semicolon, so that's all good. So if we now save and compile, what we wrote inside there should take effect. So let's have another look again and see how it is. So it looks a bit funky, and you can see there's a few bugs we need to iron out, but the camera is moving now. It's following Link, but it's not really following him fast enough. And there's also some funky stuff going on at the edge of the map, so let's deal with that. But we've made progress, and we've only got a little way to go now, and our camera function will be perfect. The first fix we're going to make is to this SBR, this sprite, set position of the sprite function we got here. So first of all, we're actually going to remove this from the while loop, and we're going to put it into we're going to insert it at the very end of our camera function. So this is where we're going to update the sprite position on the screen, and we need to make a very simple change here. All we do is we simply take the position of Link X, the integer version of it. Remember, we did the fixed 32 to int, and we're simply going to subtract the new camera position from it. So we're going to subtract the new camera position X and the new camera position Y from Link Y. And then if we do that, it already make a big improvement. And if we save, compile, and we look at the ROM again, we should see that the Link's not actually falling out of the screen anymore. He's in the center, so it's already looking a lot better. This is already very close to how we want it to be. The next issue we need to fix is to stop the camera from going over the boundaries of the map. So we can see we've got the map here, but when it reaches the edge of the map, we want to tell the camera to stop. But the camera at the moment, it just carries on past the edge of the map, and you can see the areas where it passes the edge of the map because a lot of the graphics end up repeating, and is a bit of a weird effect. It's not really what we want, so we're going to need to type something SGDK to tell the camera, okay, once you get to the edge of the screen, whether it's the top, the left, the right, or the bottom edge, you're going to have to stop moving the camera so you don't overshoot. If we check back with our map here, so this is the 0, 0 coordinates of the camera, and if it goes further to the left than that, then the X coordinates become negative, and if it overshoots above, then the Y coordinates will become negative, -1, -2, -3, and so on. Now on the right hand side and the bottom is a bit different. So if we set the coordinates to the map size, then this would be where the camera ends up, which is again off the screen. If we don't want the camera to overshoot the right hand side of the screen, then we're going to have to take the width of the map, and we're going to have to subtract the horizontal resolution of the screen, which would be 320. And if we don't want it to overshoot the bottom of the map, we're going to have to take the height of the map, and we're going to have to subtract the vertical resolution, which would be 224. So in that way, we're going to set boundaries to how far the camera can scroll and make sure it doesn't overshoot. So we're going to create some new constants to help us with this. So we're going to use the hashtag define again. We're going to define some more constants. The first two are going to be the horizontal and vertical resolution of the screen. So right now we've got it as H40 mode, so the regular 320 pixels wide mode. I'm going to show you how to do the lower resolution mode later on. So we do define horizontal resolution 320 and define vertical resolution 224. Okay, next up we're going to have two more constants, but this time we're going to record the width and the height of our map. So again, hashtag define, and we can do map height and map width. For the particular map that I'm using, both the map width and the map height is 1024, but of course if you're using a different map then it will be different for you. With those constants now declared, let's go down to the bottom of our screen of our file and look again at our camera function. We're going to write the code to prevent the camera from overshooting the edge of the map just after where we update the camera position. As you probably already guessed, we're going to need to use more if statements. To stop the camera from going past the left hand side of the screen, we're going to have to write this if statement. We're going to say if the new camera x is less than 0, then new camera x equals 0. So that means it's never going to drop below 0. So that's going to stop the camera from moving past the leftmost hand side of the screen. It's not going to overshoot the map on the left hand side. And then we're going to do else if the new camera x, and we're going to do greater than, and remember we're going to need to do a bit of calculations here, so we're going to do the map width minus the horizontal resolution. And if it's the case that the new camera position of the new camera x position is more than the map width minus the horizontal resolution, then we're going to make it equal to the map width minus the horizontal resolution. And so just in the same way as we stopped it from overshooting the left hand side of the map, we're going to stop the camera from going past the right hand side of the map with this piece of code. Next up, we can simply copy and paste the code we just wrote and we can repurpose it for use with the y-axis. With that now done, we can simply save, compile and have a look at the ROM. And we can see straight away that it's not the camera's not going past the left or the top of the screen. Now let's go to the far right to make sure it stops on the far right edge of the screen, and that's fine too. And if we go down to the bottom, we check the final side and just make sure it doesn't overshoot the bottom of the screen, so if it stays where it is. So excellent. So the only thing now that's left that you probably notice is that Link he can still leave the screen even though the map stays where it is. So we'd have to write some more code, some similar code to what we just wrote, to make sure that Link doesn't go past the edges of the map either. Just like we had to take the horizontal resolution and vertical resolution of the screen into account when deciding how far we can scroll to the camera to the right or to the left, we have to do the same with Link here. So we have to take the width of the sprite and the height of the sprite into account. So if you want to keep Link on the screen, then we need to keep him here, and of course the coordinates are in the top left hand corner of that pink box, so we can't let the X or Y coordinates go over that if we want to keep Link on the screen and not have him pass by the right or the bottom of the screen. Just as when we created two constants to store the vertical and the horizontal resolution of the screen to fix the camera problem, to fix this problem of the sprite leaving the screen, we're going to create a couple new constants, so the player width and also the player height. So these are the width and the height of the player sprite. Once that is done, we're going to go down back to our camera function, and at the very top of the camera function, this is where we're going to put the code just to make sure that the player doesn't leave the screen. To do that, we're going to need more if statements. So we're going to stop the Link from leaving the left hand side of the screen, we're going to make sure we're going to compare Link X with 0. So if Link X is less than 0, then we're going to make sure that it remains 0, it never goes below 0. And of course, because Link X is a fixed 32 number, we have to compare it with another fixed 32 number. So that's why we put fixed 32 brackets 0. and we have to do the right hand side too, and that's what we handle with this else if statement. So we're going to say if link x is greater than the map width minus the player width, and again we wrap that up in a fixed 32 number, then we have to make sure that it stays, that it doesn't go past that point, so it doesn't leave the right hand side of the screen either. And of course after that we just do the same for the y-axis for the top and the bottom of the screen. If we then save, compile and load up the ROM, we should see that everything's fixed now. So I've just tried to move to the left and the top of the screen, and it's not letting me go past where the boundaries of the map are, so that's working fine. Now let's go to the bottom right hand corner and make sure that the bottom of the screen and the right hand side of the screen doesn't scroll, so even though I'm holding the D-pad, it's not going past that point. So that's the basic camera function done now. So we don't really have any particular bugs. What we're going to do now though is just to change a few variables just to play about with it, because I always encourage everyone to play about. And what we're going to change here is the point at which the camera moves. So instead of keeping Link in the center, we're going to give him a bit more extra movement before the camera moves. And obviously what kind of choice you make on how to do your camera depends on what game you're doing and your own personal decision, the game design and so on. So it's very easy to change. We just changed these 4 variables here. Now if we now go to the ROM, you can see Link has to go very far down to the bottom before the camera starts moving, and then he has lots of leeway to move back and forth before the camera moves. This kind of camera is a bit exaggerated. I can't imagine many games where this kind of camera will be useful, especially because you end up bumping into enemies because you're too close to the screen. So in general I think you want to keep close to the center, but how close that is entirely up to you, it's your decision. And of course there's even some more complex cameras where if you face to the right, then it shifts more to the right to give you more space to see what enemies are coming ahead, and the same if you go to the left. You have to be careful with that kind of camera because it can make you feel a bit sick if the camera swings back and forth a bit too much as you turn from left to right or up and down. Before I finish up by showing you how to alter the camera code to work with 256 low horizontal resolution, I just want to take you through the code once more nice and slowly, because I know it was quite a lot to take in today. So at the top of the file we've defined 2 variables, the current camera X and Y, and we define them as global variables at the very top because we need to keep track of those from cycle to cycle, from frame to frame, and the rest of them are constants, so the player width and so on, the map height and width. And then we've got the player coordinates as a fixed 32, which is what I always recommend using. We recommend using that data type. In the while loop, of course, we have to make sure we put our camera function in there so that the game actually uses the camera function. And speaking of the camera function, that's what we have here below. So the code we just wrote now, first of all we have the code we just wrote to stop Link moving from the screen. So if he goes past, he can't be less than 0, so he's not going to move past the left hand side of the screen, so going to move past the right or the bottom. After that we create a variable that just converts the X and Y coordinates of the player into a whole number, into an integer, so we can use it later on in our code, because sometimes we need to convert it to an integer before we can use it. After that we create 2 new variables just to store where if the camera has moved, we have to store what the new camera values are, the X and the Y coordinates of the new camera. Following on from that, we have the code that calculates a new camera position. So it asks, if the player has moved, and have they moved far enough to the left, right, top or bottom to trigger the screen moving, to trigger the camera moving. If they have, we have to calculate the new values of the camera. We then make sure that the camera itself doesn't move past the limits, the boundaries of our map. So that's what this code is. So it's very similar to the code we wrote to stop the player from leaving the boundaries of the map. Next up is we do a check to see if the current camera position is equal to the new camera position, and of course if they're equal it means that there's been no change. The player hasn't moved far enough to trigger a scroll, but if they have, then we have to update the current camera position so we can use it. We keep that in RAM so we can use it for the next cycle, the next frame, and for the comparisons there. And of course if there has been some movement, we have to use the map scroll function just to scroll the map. And finally we need to set the position of the sprite on the screen, and in order to make sure we offset where they're going to appear, they don't move off the map, we have to make sure we subtract the new camera position from the actual player position. Now let's update our code so it works with the low resolution mode. So first of all we're going to change this constant from 320 to 256. So this doesn't change the resolution itself. To do that we have to use this function, the VDP. If you type in 256 we say you get this set screen width 256, and this is the function that's going to actually change the width, the resolution to 256 within our code. After saving and compiling, you can see that our new ROM, the resolution has been changed, the graphics look a bit wider horizontally, plus our camera is working fine too. So the way we wrote our code makes it quite easy to switch between the two resolutions. We have to change a couple of values. The only extra thing we have to do really is to change how far you get to the right or left before the camera moves, because the values we gave before were based on the higher resolution of 320 width resolution. So in order to, if we want to keep the character roughly in the center, we have to set these values at roughly halfway between 256 instead of 320. And from this here you can see that now the camera's looking a lot better, as Link's generally staying in the middle before he moves to the right or the left. So I think just making this little change already made all the difference. If there's anything you didn't understand, then feel free to leave a comment below, and I can try and explain it further. But I think don't worry if you don't understand anything completely this first time round. Just use the camera code as a template, just copy out exactly as I've done it, adapt it for whichever map and sprite you're using, and then just experiment with it, change things and play around with it, and then it'll give you a greater understanding. And then maybe later you can come back and you can watch this episode again, and then you'll have a greater understanding of it. Just a final note on today's lesson before we go. I've used ints as the data type for lots of the variables we've been doing, but actually you can change it to S16, which is a 16-bit number. And whereas int goes from -2 billion to +2 billion, the S16, the signed 16-bit integer, can go from roughly -32,000 to +32,000. So as long as the map size doesn't exceed 32,000, and the map size I was using here was 1,000 in the horizontal and the vertical direction, then it should be fine. So you can maybe save some data and go a bit easier on the CPU that way. But that said, it doesn't really make too much of a difference. We've only got a few int numbers here, 32-bit numbers, so it's not something you have to do, it's just something you can consider if you want to. Okay, so I think that just about wraps things up for this video. Thank you so much for watching. If you're interested in this kind of content, then please subscribe to the channel.
I'm interested in this.
And if you want to support the channel further, I have a Patreon account.
You won't go unrewarded.
And until next time,
farewell.